In this video, we are going to tackle parts and properties of a rational functions graph. And we begin with observing or studying this graph, which is a rational functions graph. And as we observe, it's made of two curves that are not connected. One curve is heading north, while the other south. This goes to the left, while this to the right. We observe that each curve seems to approach these two lines, this vertical line and this horizontal line. Each curve seems to approach this line as the curve moves towards infinity. So the curve will approach this line, but it will never touch it. We call it the vertical asymptote, while this red line here we'll call horizontal asymptote. We also observe that the graph touches the x-axis at this violet point here. We will call that point the x-intercept of the graph, and this point, which is crossed by the graph here on the y-axis, we will call it the y-intercept of the graph. We compute the x-intercept by setting y to 0 and then solving for x. On the other hand, we compute the y-intercept by setting x to 0 and then solving for y. Now we take note that the domain of a rational function contains the set or is the set of all possible values of x. We remember that when our function is rational, we don't want the denominator to be 0, because when the denominator is 0, it's like we are dividing a number by 0, and when we input that in our calculator, we obtain math error, which means the number is not undefined. While range refers to the set of all possible values of y. Going back to asymptotes, to determine the equation of the vertical asymptote, we simply write x is equal to the number that is not included in the domain. To make sense of this, later we will solve some items or some examples so that we'll be able to understand it better. So for now, we take note that the equation of the vertical asymptote is given by x equals the number that is not included in the domain, while the equation of the horizontal asymptote depends on the case of the rational function. Case A, when the degree of the numerator is equal to the degree of the denominator, the equation of the horizontal asymptote is given by y is equal to the ratio between the leading coefficient of n and that of d. So that is case A. Case B is when the degree of n is greater or bigger than the degree of d. When that happens, the equation of our horizontal asymptote will be automatically y is equal to 0. While our third case is when the degree of our numerator is greater than the degree of the denominator. When that happens, we say that there is no horizontal asymptote or it does not exist. So to make sense of all those things, let's try this example. Let us determine the required parts and properties of the given rational function, f of x is equal to quantity 3x plus 4 all over quantity 2x minus 6. Let's first compute or determine its domain. Letter A. So, according to our definition earlier, we don't want the denominator of our rational function to be 0. Now, looking at this particular example, what value of x will make the denominator 0? If your answer is 3, then you are right. Therefore, the domain of our function is all real numbers except this number 3, because 2 times 3 is 6 and 6 minus 6, that is 0. Or we may write the domain this way: x should not be equal to 3, right? We'll go back to the range later. So we proceed to finding or determining the x-intercept or 0 of the function. So according to our definition earlier, to compute the x-intercept, we will set the function or y to 0. So we'll have this. And then solving for x, we will obtain the product of these two is 0. While if I will affix 1 here, the product of these two is 3x plus 4. Did you notice something? If you notice that, then very good. Solving for x, we will obtain 3x is equal to negative 4. Dividing both sides by 3, x is equal to negative 4 over 3. This is now our x-intercept. While to determine the y-intercept or to compute the y-intercept, we will set x to 0, meaning we will replace all the x's with 0. If we do that, that leaves us with y is equal to 4 over negative 6. Or, simplifying that fraction, we'll have y is equal to negative 2 over 3. So this is now our y-intercept. While for the vertical asymptote, we will just write x equals the number that is not included in the domain, that is 3. So the equation of the vertical asymptote is x is equal to 3. Now for the horizontal asymptote, let's study the case here. What is the degree of our polynomial in the numerator? What is the highest degree or power of x here? So the highest power of x is 1. So this is in the first degree. While in the denominator, the highest power of x is also 1. So this is also in the first degree. So the degree of our numerator is equal to that of the denominator. This is case A. And when the degree of the numerator and the degree of the denominator are equal, the equation of our horizontal asymptote is given by y is equal to the leading coefficient of n over the leading coefficient of d. So that will be 3 over 2. So our horizontal asymptote has the equation y is equal to 3 over 2. Now, since this is our horizontal asymptote, it means in the range that the possible values of y is all real numbers except 3 over 2. That in symbols can be written y is not equal to 3 over 2. Alright? Did you understand this case? Alright. We move to a second example. Let us determine the required parts and properties of this rational function. So, letter A, we find the domain. So here, you should be able to factorize the denominator for you to be able to clearly see what values of x are not allowed. You should be able to see that x squared minus 3x minus 4 when factorized gives x minus 4 and x plus 1. These are the factors because when negative 4 and 1 are multiplied, their product is negative 4. This is their product. But when added, they give negative 3. This is their sum. So that is a technique which you can apply if you want to factorize a given quadratic expression. Going back, so how many values now are not allowed or not included in the domain of this function? Yes, we have 2. X cannot be 4 because when this is 4, then we'll have 4 minus 4. This is 0. And if this becomes 0, whatever the value of this, their product is 0. Therefore, x cannot be 4. Also, x can't be negative 1 because negative 1 plus 1 equals 0. And that will result to a product that is 0. So we have 2 values that are not included in the domain. Now we go back to finding the range later. So let's proceed to finding the x-intercept. To find the x-intercept, actually what we do here is we just equate the numerator of the function to 0 and we solve for the value of x that will make this equation true. What value of x will make it true? Of course, it is 3. So the x-intercept of this rational function is x equals 3. While its y-intercept, if we will replace all these terms with 0, all the x's of these terms with 0, then they will disappear, leaving us with just the constants. So that means our y-intercept will be negative 3 over negative 4. Or that is y is equal to 3 over 4. Okay? Now, since we have 2 values that are not included in the domain, then there are 2 vertical asymptotes. They are x equals 4 and x equals negative 1. Alright? While for our range, let's study the case here. So we look at the powers of or the degrees of the numerator and the denominator. So in the numerator, what is the highest power of x? We see that it is 1. So it is in the first degree. While in the denominator, the degree is second. So the degree of the numerator is less than that of the denominator, which means this is case B. And that means it's automatic that our horizontal asymptote is y is equal to 0. So that means our range is y is not equal to 0. We can use any real number except 0. Did you understand? Now we go to our last case. We go to example number 3. What is the domain of this function? Alright. We don't want x plus 3 to be 0. So we don't want x to be negative 3. We'll go back to finding the domain, range, later. To compute the... let's replace this with x plus 4 instead. So let's use x plus 4. If we are going to do that, then this will be... our domain will be changed as well. So this should not be... this should be x plus 4 is not equal to 0, so x is not equal to negative 4. Okay, going back to finding the x-intercept. So we just copy the numerator and then we equate it to 0. Then solving for x, this becomes x squared equals 9. And then extracting the square root of both sides, x will obtain two values or two possible values of x, positive and negative 3. So these are our x-intercepts. While for the y-intercepts, only the constants will be left, since all those with x will disappear. So y is equal to negative 9 over 4. For the equation of the horizontal asymptote, since x is not equal to negative 4, then the equation of the vertical asymptote is x equals negative 4. While for the equation of the horizontal asymptote, let's study the case. So this is, our numerator is in the second degree, while our denominator is in the first degree. Therefore, degree of n is greater than the degree of d. This is case letter C. And because this is case C, then we don't have any horizontal asymptote. So we write no horizontal asymptote. Or we simply write none, or does not exist. And because this function does not have any horizontal asymptote, then its range is the set of all real numbers. Right? Anything you did not understand? Okay.